Hello everybody. I would like to welcome you to today's remote lecture on EditSurfaceCommands. My name is Joe Waxmonsky and I will be your instructor. I have Wes Newman and Wes Collins here assisting me today in this lecture. Today I'm going to go over and talk about EditSurfaceCommands using the latest version of InRoads 2004 version 8.05 Service Pack 1. Today's agenda: I'm going to give a demonstration on EditSurfaceCommands and look at basic functionality of each command. The commands do a variety of different functions throughout the course of a project. So I will concentrate what each tool can do instead of trying to use them in a progressive demonstration for a particular workflow. The demonstrations given will show basic examples on how the tool can be used. This would serve as more of an introduction to someone who's not familiar with these InRoads commands, compared to someone who has a more advanced user. I will also give examples of when these commands can be advantageous during the workflow of a project. And lastly, we will have a question and answer session, so you will have the opportunity to ask questions about the content of this presentation. Let's start off with what is a feature. A feature is the name of set points in a digital terrain model. They could consist of 5 different forms. The first one is a random point, such as ground shots, which everybody's familiar with. Second is break lines. An example of this would be edge of pavements, bottom of curbs, top of curbs. The third is an interior boundary, which are footprints of a building or other objects where contouring is not needed or desired. Fourth is an exterior boundary, which is the perimeter of a surface. We will be looking at this later in today's class. And lastly, contours. They are very similar to break lines, but different in the fact that you can generate inferred break lines to help digitize them more efficiently. Functionality of the EditSurfaceCommands. Modifying features in the DTM to design and reflect modifications through the course of a project. Speed up the design process. This is a huge advantage of EditSurfaceCommands, as they eliminate the need to display the feature, then edit the feature graphically with a microstation command, then delete the old feature from the DTM, and lastly, re-import the modified feature back into the surface and retriangulate. Long story short is that these tools save you time, thus they save you money. The other function of these commands are you can change coordinate systems of a DTM. You can change the vertical datum from an arbitrary datum to a new vertical control midstream through a project. You also could translate a surface from English to metric units or vice versa. And you could also do a variety of other custom transformations. Next, you can eliminate erroneous data from the surface. Examples of this would be removing long triangles along the edges of surface that do not reflect where actual survey data has been taken, and also deleting incorrectly placed features within the DTM. The last function of the EditSurfaceCommands is they manage DTM data. That's the bottom line. It gives the user the ability to adjust quickly when the scope of the project changes or any other changes occur within the project. Before I go any further, I want to emphasize the importance of locate locks with EditSurfaceCommands. Many of the EditSurfaceCommands work with the locate lock. This helps the tools to locate either a feature or a graphical element. Locate lock will cause some of the commands to change on what it prompts the user for. First, element locks will seek a position of the nearest feature in the active surface, whether or not the feature is actually displayed. In other words, if the feature is not displayed in microstation, this lock will actually look for a feature in the DTM. It does not need to be a graphical element within microstation or AutoCAD. Next is you could actually look for a graphic element within your CAD platform. Graphic locks will seek the nearest display graphics within the CAD file. Let me give you an example of this. And here we just have a simple surface, and we're going to just go in and look at one command very quickly here. Extend features. We're going to be looking at this in some detail a little bit later on. But right now, as you can see, I have my location locks in searching for feature within the surface. So if I hit apply on the bottom, it's prompting me down here near the startup is to identify feature. If I toggle this back to graphics, it's going to ask me to identify element. Now let's begin to discuss edit surface commands. The first command is copy single feature. This duplicates a single feature within a surface or another surface. This can be used to take an existing edge of pavement from an existing DTM and place it into a proposed DTM. This copied feature will provide a perfect tie-in with the existing surface. When you model from a copied existing feature, let's take a look. I'm going over to the, let me close this up, the copy single feature. I'm in my surface existing, which is represented by these contours here. I have my locate graphics. I want it to be element, so I'm going to have that. I'm going to use the button bar to locate this particular feature. I'm going to accept it. I'm going to put it into a new DTM called proposed. This DTM is empty. I'm going to give it a name of edge of pavement. I'm going to leave the description blank for now, but I am going to give it a style called break line. Then I'm going to hit apply. As you can see, it was a successful completion. We could go into the edit surface, feature properties, and look into proposed, and we can see that feature has been copied from existing into the proposed surface with the symbology of break line. So basically, we saved us the time of displaying this graphic, importing it, import surface by graphics, and putting it into the proposed surface. Before I was mentioning this is a perfect tie-in feature, and I'm going to give you a short little example of how we can model, site model a little pavement widening in this section right here. I'm going to go to Surface, Design Surface, Apply Decision Table. I'm going to have the information go into the Design Surface Proposed. On the right side, I have my intervals and stroke tolerances set up. I'm choosing widening. I have the final intersection name as final name, and I'm going to hit apply. I'm going to identify the primary feature. Yep. Let's try this again. Alright. We grabbed the wrong feature right here, so we're going to go back really quick. And we're actually going to use the edit surface command to fix our problem. We're going to delete this feature out of here. I'm going to show this in more detail later. Hit apply. Delete this feature. Close. And I'm going back into the copy. I'm taking it from existing. I'm going to accept it. I'm going to the surface proposed. I'm going to repeat what I did before. Edge of pavement, style, break line. I'm going to hit apply. And again, I'm going to verify within the feature properties of proposed that it's there, and it is this time. Now we're going to go to that example I was trying to show you before. under Apply Decision Table. I'm looking in the surface proposed where I put that feature I copied. I make sure I got all these set up correctly. Hit Apply. Accept primary feature. There we go. We got it this time. We're going to accept that. We need a reference feature. Accept. And we're just going to go from this inlet to about that inlet right there. We're going to close that up. And you can see a gray line representing the edge of pavement, and we just have a simple cut slope here. Nothing too complex. We're going in to triangulate this proposed surface. And we're going to view contours of this proposed surface. And I'm going to make the symbology different so you can tell the difference between the existing and the proposed here. Apply. And as you can see along this break line, which we copied from the existing feature, we have perfect tie-ins along these contours. Next, I would like to talk about Edit Feature Point command. This is a powerful tool. It's like the MicroStation Modify tool for DTMs. You can edit, add, remove vertices data in a feature. This tool can be used in a variety of different functions. But let's say you have an intersection with flat grades and the drainage is a high issue. This tool could examine your curb returns around an inlet and make adjustments to the curb returns to force positive drainage. Let's switch over back to MicroStation. And I do have an example. I'm going to let WebEx catch up here. I have a simple intersection here, small schematic. And I have a feature going along this line with an inlet. We're going to open up the Edit Feature Point, and this is in a different surface than what we created before. So we're going to go to the Edit Feature example that I have. I have a feature curb in here. This is the curb return that I was mentioned before. And in here we could use the button bar to pick the feature we need, but in this surface we only have one feature. And the points we're concerned about are the ones nearby this inlet. So we're going to use the button bar just to get us a little closer. So we're on point number 9 out of the 20 points to find this curb return. If we look at it, it's elevation 1021. We could progress forward. We have 1040, 1046, and 1030. This area in here with this inlet being stuck in this location is not going to have positive drainage. So what we could do simply is use these tools to modify what's going on here. We have two points very close next to each other. So what we could do is we could actually use this command as one of its functions to delete one of these points. All you need to do is hit delete. It didn't take place yet until I hit apply. The feature is automatically updated. And now we could examine how to improve this even further with a variety of other tools. Right here we have point 10 at 1040, and this is at 1030. We're going to lower this one down to be under 1030 for spot elevation on the curb. So we're going to just simply key in 1025. Hit apply. Now we can examine 130, excuse me, and 125. And then right here we have 100.21. So now we have drainage flow running down this curb into the inlet, which would be reflected in our DTM, thus would be reflected in our cross sections generated from this DTM. The other thing, this tool is very powerful in many regards. We could actually insert a point. And when you insert a point, if I'm here, it will insert a point halfway between the next point. So I'm just going to hit insert, and it's actually right here. And it just basically takes the slope between these 2 points, interpolates where this is going to be, and adds a vertice. This vertice later could be modified with these commands, and etc. There's some more features here. You might be wondering what these are. This gives the head and back along this feature on what's actually going on here. We can actually see the slope. So if we go back, we can see we have a nice slope of negative 4.3. Water would flow this way. And then if we continue forward, you can still see that working all the way through. So there's a lot of different ways we could use this tool. Another function of this tool is we could actually have a discontinuous feature. This is with this toggle right here. So we're going to go up a little bit from here and say we're going to move the view a little bit. Say we do not want any break line to be here, but we want this to maintain one feature. Start discontinue. Make this discontinuous right at this point. Hit apply, and it's removed from this feature. You might be wondering if this is actually 2 features, but in actuality, if you go under Edit, Surface, Feature Properties, it's still 1 feature. We only have 1 feature within the surface. It did not make it into 2. Next, we have Divide Feature. This tool could be used to add vertices along a given element at a specific interval. This can help resolve contouring issues that arise from long slender triangles being formed due to lack of vertice information along an element. Zoom out here. Here's an example of a bank. Very simple. We didn't want to get anything too fancy with it. But bottom here we have a feature with 1 vertice point here, 1 vertice point on the other side. This feature has a lot of vertices defining it. As you can see, the contours in this section are doing things that would be pretty much undesirable. If we go under Surface, View Surface Triangles, to examine this a little better, we'll go under my divide example, hit apply. We can see we have very long triangles stretching because there's no vertice information within the feature on the bottom of your screen. So we're going to use the divide feature command. We still have our locks on for feature. I want to add it to this feature right down here. I'm going to apply it. It's going to automatically find that for me. So if it's a very large surface, this button bar could be handy, save you some time. And we're going to add in it vertice point every 10 feet. Hit apply. Close this up for you. You can see all these vertices added through here. Now let's see what the results would actually be. We're going to go in and triangulate this surface. Our divide example. We're going to hit apply, close, and then we're going to hit surface, view surface, contours, just to see what the difference would be. I have this in pencil, so when I hit this, we'll have new contours generated. It's a different symbology because it's proposed, but as you can see, those erroneous contour lines are fixed. And just to see the things in the background, we'll look at the triangles also. You can see we have a much better proportion of triangles not being stretched out all the way across this DTM. I'm going to delete those triangles. Next surface command I'm going to go over is the reverse feature direction. Simply does what it says. Takes the beginning and makes it the end. Great for design surface tools where you need to define beginnings, or when you want to specify the direction before you join the feature together. This is not a tough one, so let's speak of it quick since there's a lot to cover today. This previous surface we were looking at, we're just going to show you that this is point number 1, and over here is point 28. And we're going to close this up. We're going to hit this button. It's going to prompt us to identify a feature. Accept it. And then we're going to go back. And as you can see, point 1 is on the other side. Next surface command is delete feature. It removes the feature, it cleans up mistakes, or removes duplicates. This is also an easy one, but I need to stress the importance of feature filter on sorting through large DTMs. It saves a lot of time. This is why well-chosen feature names during importing information into the DTM is very important. By choosing logical naming convention, one can utilize the feature filter to the maximum. Switching back, this command is right here, and it has the same setup as the other commands we looked at previously. Button bar. We can actually just delete this surface, this feature right here. Accept it, and the feature is removed. Easy enough. Next is the partial delete. One must note the snap mode when you're using this tool. The other important fact is that you can delete a feature in the middle, and the feature will be still under the same name. It will be discontinuous feature like we saw before. I'll show you what I mean. Refresh the graphics. Use the partial delete command. It's prompting us to identify a feature. I'm going to just use this break line here. Notice I could choose anywhere on the surface. If I change the snaps, the point, I'm going point to point on this. So right now, I'm just going to delete from here, partial delete to there. If I used the element command, the snaps for element, where I could choose this feature and delete from here to there, new vertice points will be where that discontinuous section is in that feature. Next command I'm going over is break feature. Takes a partial delete one step further. This command will break a feature at a point you specify into two distinct features, using the first feature's name as the C name for the second. The join feature is the exact opposite as the break feature. So I'm going to look at these two together. And here's the break feature command. I'm going to identify the feature. I'm going to accept, and then since I have no point snaps, I could break the feature anywhere along this element, and if I go back to point snaps, I could break it right, let's say at this vertice point. I do that, it looks like nothing has been done, but if I go to surface, feature properties, and highlight this one, you can see this is a distinct different feature from break 11 from break 1. Conversely, as I mentioned before, the join feature is the exact opposite. So basically we're just going to identify the first feature, identify the second feature that we broke before, identify, and go back into edit surface, feature properties again. Didn't accept that. Hold on, let's go back. Identify first feature, accept. You need to identify the second feature, accept, feature properties, and now you can see break 1.1 has been removed and it's been put into this feature right here. It's all one discontinuous feature. Next command I'd like to go over is trim feature. Trim feature allows you to trim a feature with either another feature or a graphical element. The locate locks is also very important with this feature. The extend feature is the same as the trim, but it's working in the opposite sense. You're extending it to either a feature or a graphical element. And also the locate locks is very important for this actual command. Let's go into MicroStation for an example. And let's go to a new section. I have a surface down here. And this surface where I'm pointing to right now, I'm waiting for WebEx to catch up here. These contours represent the existing surface. Up here is a channel that's been a proposed channel. It's very simple, straight. But if you notice, our tie-ins at the ends do not tie in with the existing. So we're going to use the trim and extend commands to actually tie this into existing. What I've done out here, you'll see two white lines, one on the beginning of the channel and one on the end. These lines are draped on the existing DTM where the channel is. So what we're going to do is we're going to first go to extend feature. This is a different surface, so we're going to go to our channel. We get choices for elevation. We have do not change. In our case, we want to match the existing where we drape the line on the existing surface. So we choose match at existing. I'm waiting for WebEx. We're going to choose, we could just hit all, hit apply. It's going to ask us to identify feature. And since I have the wrong locks on, this is what I was saying, it's looking for a feature. So I'm going to cancel out, go to graphic, reset the command, hit apply, identify element this time, not feature, accept. As you can see, the features were extended to this line. This line's elevations are at the existing surface elevations. So these extended features are now also at that elevation. If you also notice, we're missing a few on this side. You're probably wondering why, because this is the left side and the right side of the channel, and we're missing the left side. What happened here is this feature is one feature, but it's discontinuous. So what we need to do is break this feature from channel. Excuse me, let's close that dialog box up. Break feature. And we're going to get right in there. You can see the both sides highlight. We're going to accept it. It's going to prompt us where to break it. We're going to break it right there. But since I already modeled this part and it's already in the DTM, I'm going to undo this. I'm going to load that channel again. I'm going to overwrite what I had previously done. And I'm going to go back to that extend command. But this time I see there's just three, and I know I have to break those features to have this work properly. So I'm going to close this, going to break this feature again here. I'm going to break this one, and I'm going to break this one. We go to Surface, Edit Surface, Feature Properties, and now in the channel you can see before we had 3 features, now we have 5. So we should be good to go with the Extend feature. So I'm going to go back. I'm going to hit All. Make sure I have my graphics. Hit Apply. I'm going to identify my element. Accept. And there we go. These features have been extended to this graphical element. And conversely, we're going to do the same thing with the trim feature command on the other side. So we're going to select all. We're going to match that intersection with elevation, and we will want to cut one side. The one section, if you have the element meandering back and forth with among the cutting element, it will only cut one instance of it. We want to cut every instance in this case, so we're using it to one side. We're going to apply, choose the graphical element, accept. Those features has been automatically, well, we have to choose what side to delete, and we want to just delete this side right out here, and those features have been trimmed. Alright, we're going to view surface contours to show the new channel. We're going to hit apply. We didn't retriangulate, so we're going to need to with those modifications. Close, close, and you can see those edits been made. We need some more work down here to actually tie it in at the beginning here, but as you can see, the extended features nearly match in. The next command I like to look at is the intersect feature command. This command extends 2 features to a point of intersection. The features may exist in different surfaces. This command is very similar to what we were just working with, and we've been running out of time here because we have a lot more to cover, so I'm going to run over this pretty quick. Here's the intersect feature command. We're going to go back to our feature locks. We're going to change our. We're going to just use this channel surface for both, and we're going to intersect this one, uncontrolled 1, and uncontrolled 2. As you can see, the intersection would be way down, so we're going to have to zoom out. But right here we have elevation do not change, our match at feature 1. If we do not change, both features will interpolate the slope between the last 2 vertices and extend that out, and there would be 2 vertice points at the intersection. In our case, we want to match at feature 1, so we'll take that interpolated slope along that distance where the intersection point is and use that elevation for both features that are extended. I'm going to zoom out. We're going to hit apply. And we have multiple instances. We either could be this side or that side. They'll give you each one and it'll cycle through. Your cursor will control where it's going to go. In this case, we're going to just put it over the top, accept it, and close it. Now I just want to zoom in here and show you what I was talking about with the elevations. We have elevation 290 on both elements that are intersecting. If we didn't have it use the first element, there would be 2 different points there. Next command is copy portion of surface. You can use this copy portion surface command to copy multiple features from one surface through a feature filter and/or a fence. This can be used to break a large DTM down where it could be cumbersome working in a small area when you don't need all that extra data, and the processing time could be much too long for what you need it for. The other great use for this tool is to troubleshoot surfaces that have difficulty processing. So you can examine a smaller area and narrow down trouble areas. This tool provides an easy way to manage DTMs. Go back into InRoads. Okay, let WebEx catch up here. We're going to put a fence on this portion of the surface, and we're going into the command, and we're going to change it to our existing 2 surface, which is represented by the contours that you see on your screen. It's under this dialog box where our fence is. We get a choice of where we're going to copy this surface to. We could put in I have a surface called copy portion. It's empty. We're going to do inside, and we chose all the features. We could use a feature filter on this, but for simplicity we're just going to use all of them and basically let the fence govern what's going on here. I'm going to hit apply. I'm going to close this dialog. I'm going to triangulate copy portion, to apply, close, and to show you what's going on, we're going to display the contours. I'm going to ignore the fence, and we're going to use a different symbology. Apply. And as you can see, in this section we have solid lines on the contours instead of these dashed, and it just extracted this portion of the surface into the new surface. The next one I like to cover is merge surfaces. It combines 2 surfaces into one to add additional topography, to merge an existing with a proposed to reflect post-construction conditions, which then later could be used for graphic renderings. Also, it could be used to show updated surfaces to reflect construction staging. For example, stage 2 contouring can be modeled on a combination of stage 1 and the original existing surface once they've been merged. This tool will be featured next week by Wes Newman, so I'm going to just touch on this a little bit and give you a few examples. We're just going back to our channel, and we're going to go to our merge surface command, and we want our existing 2 to be original, our design to be channel, and our destination to be this empty surface called merge. We don't want to retain any of the original surface points because where the channel is, we want that to be what is dictated in the contouring. We want to retain all features excluded from triangulation. If we had utilities in there, that they would be carried along. That's a perfect example of that. And we wanted to add a break line between the design surface and the original surface, just to keep the contouring controlled between the 2 during the merge. We have selected all our features. We're going to hit apply. Close this dialog box. We're going to need to triangulate the new surface merge to a larger surface. Close. And we're just going to show the new contours of this. We have the surface merge. We're going to ignore the fence again. We're going to have, let's see what preference we have proposed. That would be fine. And we're going to hit apply. As you can see, where the channel is, somewhat a little difficult, a little clutter. But we can see that these contours actually run directly through, and the existing contours where the channel is actually do not have that new symbology that we just showed. And like I said, Wes Newman will be going over this in great detail next week. Next command is the transform surface command. This is a great command because everybody wants to get the job going once the paperwork is signed. Some information might not be available in the beginning, like the vertical and horizontal controls, which coordinate system is going to be used, even what type of units the job is going to be. But the DTM can be transformed after it has been created to correspond with the changes. Thus, some of the upfront data could be done and changes could be made midstream. This tool has advanced features like least square adjustments and other advanced items. I'm just going to look at the few basics today. Going to zoom out a little bit here. Go into my transform surface dialog box, and we're going to actually take this original surface that we just merged, called merge, and we're going to put in a destination surface called transform. We're going to use a method just custom. We're not going to use a fence at this time, but we could if we want to just transform a certain portion. We're going to select all our features, and we're not going to empty our destination surface because it already is empty. Under the methods, here's some predetermined things that we could use: feet to meters, and vice versa. Like I mentioned before, relative elevation if the vertical datum changed within the job. We're just going to use custom for this example. Right now we're just going to take a surface point. Usually this would be a control point within the job, but we're just going to grab this arbitrary point for right now, and we're just going to grab another arbitrary point in space. And we're going to also assume that this job, the vertical datum's changed. They found the controls later on after the survey and the DTM has been processed, and we know it's a 200-foot difference, so we're going to just type that in for our destination point. And as you can see with custom, I still have the custom command for the metric conversion. It kept the defaults, so I'm going to just put that 1:1. I'm not going to change the scale or anything of that nature. I'm just going to simply pick up the DTM, move it to a new spot, and also raise it up 200 feet to the new vertical datum. Going to hit apply. We'll close this dialog box. We'll triangulate this transform. Hit apply. Close. And we're going to view these new surface contours for transform. We're going to hit apply. And you can see the exact same surface already moved. The interesting fact is if we look at this DTM over the original one and snap to it, we have an elevation of 295 on this contour. If we go over to the next one that we just transformed, it's 495. This is a nice way to redisplay all your contouring. You're not tied to your existing contouring. You could just easily make the vertical datum change, and you could progress with the actual design of your project. Last, I'd like to go over delete triangles. This is the most used tools of the bunch. It's been around for a while. The delete triangle command removes surface data where no survey is present. This is helpful for exterior boundaries because every time you triangulate a surface after deleting triangles, the triangles will reestablish where you have deleted them. Let's go in back to InRoads, and we're going to go back to our first surface. I got to pan out here. And I'm going to zoom in on the first surface we went to. Let WebEx catch up. We're going to actually view the triangles first of this surface called existing. We're going to hit apply, close. What I'm talking about is particularly like this triangle. All these contours here do not represent any survey data that's been shot in the field. If we go in here, hit apply, we can delete the triangle, and we could go even delete some of these we also know are erroneous. So we're going to delete these, accept. We're going to close this dialog box out, and we're going to delete the triangles out of your view to clear up the screen. We're going to view surface contours for existing. To press apply, and we have a different symbology here for the contouring, but the point has been made. These contours has been trimmed back. The issue really lies is if we go and make edits to the surface, add more features, we're going to need to retriangulate the surface. So if we triangulate the surface, again, hit apply, close, view surface contours again, hit apply, they're back. If this is a very large DTM, this could be quite time consuming. So we're just going to go through, lastly here today, a workflow to add exterior boundary by using this EditSurface command. So we're going to go back, delete the triangles that we did before. We might not get all of them, but we're going to just get a few to make the point. Accept it. We're going to close out this box. We're going into View Surface Perimeter of this surface called Existing. Apply. Close. Now simply, we can import surface from graphics. We're going to import it to this surface. We're going to just use a single element. We're going to call it Exterior. Feature style. I believe we have an exterior boundary right here. And the point type, as we mentioned before, is exterior. When apply, will be prompted to identify the element we want to bring in. Tag it. Accept. Close. And we're going to go in, triangulate the surface. And lastly, we're going to go View Surface Contours. And we're going to display these again. And these changes, we still triangulate it, yet these deleted triangles had not come back because we added this exterior boundary. That will conclude our class today on EditSurfaceCommands.